And I need you to remember, before we go into this, that if you're doing a regression, first of all, clear everything and make sure plot 1 is turned on. Zoom 9 does not respond. Zoom 9 does nothing, right? Like I'm going to try it right now. Plot 1 is off. Zoom 9, it's not going to know what to do, right? It's not going to go find the points. So you need to turn on plot 1 if and only if you're using L1 and L2. When you're performing a regression, then you turn it on. If you're manually typing in an equation that's provided, make sure you turn it off, because quite often it will give you some kind of error. And if you read, it will say something about your plot. Okay, so turn it off or on accordingly. And here we go. Okay, regressions involving a context, right? Context is a word problem. Regressions and scatter plots. You may be asked to create scatter plot of data in addition to any other graph you're asked to create. In this case, all the same rules of graphing apply as with graphs of equations only. So from time to time, the province on the exams, they would say, hey, sketch the scatter plot of this function. And students are like, what? I know how to do lines. I don't know how to do scatter plots. But really, if you have points, you would just place them like that and don't connect the dots. Don't connect the dots if they ask you to do a scatter plot. And so they would give you points, of course, and then you just go ahead. The same rules apply, right? You want some kind of label here, right? Label and units, right? Label units. You want y equals there. You want x scale, y scale. Same things apply. That's what we're looking for, labels. And then, of course, the points actually being where they're supposed to be, right? Goes without saying. Dion, do you mind closing the blind there? Thank you. And this is a bit of a graph checklist in case you haven't heard me mention it enough. Here it is in written form. Okay, so basically same thing that I've always talked about. Let's dive into our example, shall we? Example 1. So at first we're just gonna listen carefully. We're gonna be dealing with problems where the points are given. Points are given. Soon it's gonna be partially, some points are given. You need to come up. Remember the story in quadratics? Remember the story coming up with that third point? Well, that we're going to do that too. So let's go ahead and talk about the example. So carpenter is repairing a wooden arm for a chair and takes careful measurements. If he can determine an equation to, he can get a computer-controlled cutter, CNC machine. Anybody familiar with those? To make a matching arm. The arm has a horizontal length of 45 centimeters. That is worth highlighting. That's not just random when you're given some kind of number there. It's like, hey, this is how long the armchair would be horizontally. He finds the following data. So there's horizontal position, vertical displacement, and there are the points. You should right away know that, hey, I'm going to type this into L1. I'm going to type this into L2. And so let's go ahead and do that. We don't know what kind of regression we're going to use. You don't know that. So let's go ahead and do this. So you press there. You press stat, not cosine, sorry. Come on, stat, edit. Go to the top, hit clear, enter. Top, clear, enter, like that. And then 0, 5, 10. These do not have to be, you don't have to have a pattern here. You don't have to have a pattern. It is what it is, okay? Sometimes there is a pattern, sometimes there isn't. And then 5, 1.36. Okay. In case you don't know what a CNC machine is, um, you know what a 3D printer is, right? A 3D printer has coordinates, and it just goes all over the paper, right, or the build plate, right? And it just moves around. It has X, Y, and Z coordinates, right? And so this is kind of like the same thing. It's just we just have X and Y, and so it's going to cut out that arm in whatever shape you're interested in making it. So, anyways, we've got this. Let's make our scatter plot, right? We want to look at our scatter plot. How do we do that again? Zoom 9, zoom stat, right? What does that look like? Linear? Right? Quadratic? Not really. Cubic, right? Would you agree? It looks cubic to me, right? Scatter plot looks cubic, right? Therefore, we're going to go cubic reg, okay? So stat, calc, oh, I'm so used to quadratic, especially when you teach grade 11 applied. Cubic reg, let's get that right. Cubic regression, that's what we're going to do. So we perform a regression, we press stat again, calculate, and we're going to go all the way to number 6, cubic. I don't want you, don't put down 4, 5, 6, right? Write down the regression that you're doing. That would be my preference, okay? And then you hit enter. And by the way, if you hit enter right now, without doing the whole L1, L2, whatever thing, you can just hit enter and it will come up with the equation, but it will not paste it into Y1, right? So right now, if I hit graph, nothing is going to happen. That's why I want you to, if you go back to the home screen, I'm just going to go copy cubic regression, and I'm going to give it those inputs. And notice there are 2 commas there, okay? Very important. And so there's my and here you have to be careful. I did not foresee this. Maybe because I used the old calculator to make this. I have a non-colored screen calculator, which is a lot bulkier. Did you use them? I think you used them. So we need to fix this. Can you go up here with me? I think this will fix it if you do the following. Okay, press Y equals. I think this is gonna do the trick for us. No, it's still not. It has it at scientific notation. So I'm gonna go back to my home screen. You got to go back up to cubic regression and run it one more time. It's one of the downsides of this calculator. Run it one more time. Up the top here, right here, I'm going to fix this problem. So we have negative 8.849196, right? And it's really times 10. You see this at the end here? Whenever you have that, it's really times 10 to the negative 4. And so what does that tell us about the decimal? What are we going to shift it left, right? 4 places. That's what's happening here. So you take this, and I will go like this: 1, 2, 3, 4. That's where it's at. So let me just write it over here. Okay, so we've got 1, 2, 3 zeros. Like you fill the valleys with zeros, right? So it's 0.1, 2, 3 zeros, right? According to this, it's not going to happen very often. And then I'm going to round that to a 9, right? This 8 rounds to 9 because of that. This is not going to happen very often, I promise you. But in this case, it did. So I'm actually glad it came up here, right? So this is now my equation. Don't forget the negative, yeah. Don't forget the negative, very important. And then it's plus 0.05 0.97x squared minus 1 point, I'm just going to go minus 1x, that's good enough, and then plus 5, because the 1 has 2 zeros behind it. So this is my cubic regression. Did this make sense up here? I hope it does, right? I'm trying to think how else I could help you here. This is the only other thing that I know how to, what I would do perhaps is minus, if you go minus 8.49, you type that in basically, 196, you go times 10 to the negative 4, like that, and you're like, nothing happened, Mr. Dixon. It's a waste of time. You go plus 1. You just add 1 to that. What's happening there? That's not right. Plus 1 like that. Never mind. Don't use that. Just use this. This is correct. I don't know. Don't know what happened there. Just go by that. You're good. And so now we're going to determine the equation of best fit. Oh, sorry. There. This was just to justify what you should have used, but we should have done this part in here. My bad. What is the highest vertical displacement? The highest vertical displacement. So obviously they're asking us to find second trace max, right? Let's go ahead and do that. We graph this thing. There it is. Do you remember how far horizontally this armchair is? Do you remember that? We highlighted it up here, right? It goes to 45. I'm just quickly going to look at my window, and I notice that X max is 44. I'm going to go a little bit past that. X max is 50. In this case, guys, remember the window is pretty good here. I don't need to make a lot of changes to my window. It includes the X and Y axis. It includes the intercepts. So don't touch that, okay? So let's go ahead and find the max. It's up here. Second trace max. And I'm to the left of it, so enter. Go to the right of it, you hit enter again. Enter one more time. And it's at a, and you know it's still within the domain, right? You're not past 45. That's something to look out for, and it's 5.05. So I'm going to write down both coordinates. Okay. So highest vertical is 5.05 what? You got to go back to your, this could be milliliters volume, like you'll see in a bit that this can be all kinds of different units. So in this case we have centimeters. So that's that. What is the zero of the curve? What does this represent in words? Okay, zeros are x-intercepts, or also known as roots. Okay, they all mean the same thing. So let's see if there are any zeros. So we're going to find, we go y2 is equal to 0. I don't even know if there's going to be a 0. Okay? We don't know that for sure. So we're going to go second trace 5 after we type the, and basically just go closer to it and then just hit enter 3 times. There is one. 11.620. So y2 is equal to 0. This is how you tell me how to find it, right? And then it's 11.620. And let's find the other one as well. Second trace 5. I'm going to jump curves. I'm going to go to the horizontal line, and it's going to be way at the end here. Is that still permissible? 44.99? Still within the 45, yeah. Wait a minute. Wait a minute. What's that e to the something there? Should I write that down? Should I put 5.9 negative? Don't do it, right? E to the negative 12 is so small for us it's 0. Chemistry, you'd probably use it, right? Significant values, right? And so it represents, in this case, it would mean when the arm reaches the bottom of the table, the building surface. Okay. So that's your cubic regression there. I could ask things like how long does the arm stay at or above. Let's, I don't want to do that right now. I just want to do another regression. But I could ask you a bunch of questions just like before. How long, like for how long does the arm stay at or above 3 meters, let's say. Okay. So there it is. So you'd have to find out how long it stays at or above the 3 meter mark. So you need to make sure you know how to do that. So I would find all these intersections here. You take the difference to figure out like the horizontal distance spent above here. You would also have to find it for this little stretch and then add those up to get your final answer. Oh, there's more. State the y-intercept. Y-intercept is 0, 5, right? It tells us the initial height or vertical displacement of the arm. Okay. Let's graph this scenario. Sometimes you can write more to it depending on the situation. In this case, I didn't have a whole lot to go by, right? So we got to go distance in centimeters, or is it called horizontal? Yeah, horizontal position, vertical displacement. Let's just do that. Horizontal displacement. And here we have vertical displacement. And that's also in centimeters. Make sure you have your units. If I remember correctly, I have to make sure I have 45 here. So 5, 10, 15, 20, that's not going to work. So I'm going to go 10, 20, 30, 40, 50. That works. And what's the highest I go on my Y? I actually don't think I found the max. Did I? I did find the max. 1 second. I have to peek. Yeah, 33.73, but the highest Y is 5.05, right? So I just need to make sure 1, 2, 3, 4, 5 that works. Just make sure that you mark clearly if I give you grids like these, you are very clear as to where the number goes, okay? And then you're good to go. So 0, 5 is my initial. At 33, this would be 35, so 33 is right about there. I'm at my highest point, which is 5.05, which is not much higher. But I'm just going to make it slightly higher than my initial. And I'm at 45, basically. Like that x-intercept is so close to 45 that we're just going to put it right there. And I need to find the min, right? If it's not asked of, or did we find it? I don't think we did. So let's go ahead and find that real quick. I'm going to do that on the side here. Second, trace min, because you want to have those turns and you want to have the intercepts, okay? Oh, that min is an x-intercept. I get it now. I get it. That's why I didn't ask for it. Hey, let's pretend like we didn't know that. And this is pretty much 0 here. Okay. So 1121 is right about there. No, it's more like this is 15 here, so 11 would be there. Okay. So you just go down and back up. What an armchair. Anyways, it's because the scale is different, right? If you were to spread this, right? If you were to spread this over a longer stretch, it would be a bit flatter, right? It would be a little smoother. But hey, this is based on our scale. This is still accurate. State the restrictions of the domain and range. So we have to put a restriction on this function or else everything is included, right? And the negatives. So for the domain, we are going from 0 to 45. That's actually stated by the question. And the range, we do get to 0 all the way to the highest point of 5.05. And if you're like your set notation, in this case, you may use x and y because they did not give you an equation. So you can use x and y. Sorry, you can't see that, can you? Write an equation that would result in the arm being taller. Answers will vary here. So I'm gonna, was it 3 zeros, right? I'm just gonna run the regression again here so that you don't have to. And that's 0.0597x squared minus 1x. We made that 1x plus 5. Sorry, so I'm going to make this plus 6. Right? Plus 6 would be the taller part. You could go 1,000 if you want. That'd be a chair for Mr. Dirksen, maybe, right? Taller guy. Anyways, that's a cubic regression right there. It's going to get a little complicated down the road when you have to make your own points. Maybe it's already complicated, but once you have your equation, everything is the same as before. So let's keep going here. I want to do a quadratic. Is this going to be a quadratic? We'll see. A steel cable that is part of a suspension bridge hangs down between the two main support structures on either end of the bridge. An inspector takes measurements of the cable and finds the following data. Immediately, you should recognize, right, you've got your X and your Y. That's probably a good idea to do that. And again, we have horizontal distance and height above the bridge surface. Read carefully here. It's not with respect to the ground, it is with respect to the bridge surface. So we're going to enter that into our calculator like before. Edit, clear, clear, and the first row is our x value. I haven't done a whole lot of linear, you might have noticed. Linear isn't as complicated. I spend more of my time in quadratics and cubics, and that's the reason why, because I feel like these are more complicated. But don't think that there are going to be no linear questions ever. There will be from time to time. So you enter all of that. You press zoom 9. Oh, I still have my previous so zoom 9 is just to look at the scatter plot. I would still say you'd have to adjust your window. Okay, but we do have, right, scatter plot. So we go L1 is the horizontal, and L2 is the height. Okay, so we go zoom 9, zoom, and then zoom, stat. See, I'm gonna do this because when you look at your notes for exam, you're gonna be like, what happened here, right? Scatter plot looks like a parabola. That's the shape of a quadratic graph, right? That's what we call it. Therefore, quadratic regression. You're gonna have to perform a quadratic. So let's go ahead and do that. If you can follow me, that'd be great. So stat, calc. In this case, I'm gonna do quadratic regression. The whole L1, L2 thing. And here we go. We have no problems with this. Right? We go stat, calc, quad, reg. You have to tell me what kind of regression you're performing. And so this is 0.0035 x squared minus 0.3807 x plus 12.16. Okay. Think of the long weekend, guys, as you're trying to stay awake for this. Anyways, what is the lowest height the cable reaches? At what distance from the first support does this occur? First of all, let's graph this. Let's make sure we have our graph. I'm going to change my x-min to slightly past into the negatives. My y max, I'm going to for now go a little bit bigger. Y min, I'm going to go -5 perhaps, and the y max, I'm going to go higher. I'm going to go 15 or something like that. So there you see your x and y axis. No x-intercepts, so that's different, right? It's pointing up, which is what we expect a cable, right, that's supporting a bridge. So the lowest point, let's go ahead and find that. That would be min, right? We're finding a min here. Left boundary, right boundary. 54. Second, trace min. And this is always this is where you will lose marks for no reason at all. All you have to do is one extra step. Don't just give me this, okay? Don't just give me the coordinates like, hey, you figure it out. Like, I know, right? I know what is what. But lowest height is 1.87 meters, right? At a distance of 54.04 meters from the per support. Okay. So you found the vertex basically. So now I can ask you anything I want, right? Just like before. Okay. Both support structures are 10 meters above the bridge surface. Calculate the horizontal distance between the supports. How would you do this? I'm curious here. So both support structures are 10 meters above the bridge surface. Calculate the horizontal distance. So I want you to imagine your support, right? And you've got the bridge here, right? And so they're 10 meters above, we know that, 10 meters. And unless, right, so this is the bridge. So they're 10 meters above. So we need to figure out the distance from here to here. This is what you're trying to find. And that's the difference in x values, right? So we know that this is happening here. All right. So how would you do that? Notice that this, when you look at this graph, it's just the function. You're just graphing the function. But we know that the height of 10 meters is where we want to hone in on, right? This is basically the post. This cable attaches right there, and it attaches a little further down here. So I'm going to increase my window, the X max to what would you say, 125? Something like that. And there it is. So you kind of have to imagine one of the posts is right here, the other one is right there. So we want to find the distance between them. So let's go ahead and find that. So I'm going to say y2 is equal to 10. Second, trace, intersect. And I'm going to go and do that right now. Second trace 5. Enter, enter, enter. You've got 6 point, that's basically 0, 0. So 610. Oh, I told you 4 decimals, right? My bad. 6.002610 is the first instance, and the other one is second trace 5. I'm just going to go across the other side. It's hard to see, right, on the screen. And that is 102.069010. Okay? So you can't always assume that the y-axis, for example, is the support post. Not necessarily. You're modeling the cable, right? And this is how you did it. And so you're now saying, hey, it's between there and there. So I'm going to figure out the difference. So delta distance would be 102.06 and so forth minus 6.00 and so forth, right? If you don't have to lose marks, oh, what did I do here? Oh yeah, that's good. Never mind. That's 96.07 meters, right? Distance between supports, right? So there you have it. Interesting stuff, eh? Anyways, let's graph this thing. Graph this stretch of the curve between the support structures. Between the support structures. So, yeah, ideally I would have wanted the graph on the same page. I couldn't make that work. Okay, distance and height, both are in meters. My distance, I need to include what, 102 or something, right? 102. I'm going to make sure it's more than that, but let's see here. 50, 100. No, that's, I'm going to go 25, 50, 75, 100, 125. And my height, I'm going all the way down. Well, obviously 0 will be fine here. And what's the highest? 10 meters, right? So 2, 4, 6, 8, 10. There you go. That's going to work. 2, 4, 6, 8, 10. 12, just for good measure. So the first one happens. It's obviously at a height of 10. I need that x value. What was it? 6 point something, I believe. So this would be 12.25. Sorry, 12.5. So it's about there. Right about there. And the other one is at a 106. This would be 112. 106 is right about there. I'm going to go up and put it right at the 10 mark. And then my lowest point was at, I have to peak, sorry, 5404. So this is 50. This would be 62, right about there, 5404. And what was the height again? 1.87. That's closer to the 2 here, right there. And away you go. There you go. Did I forget the equation on the other one? Well, here it is. Just going to run the regression one more time. 0.0035 x squared minus 0.381 x plus 12.16. Right there. State the restriction on the domain and range. If you're still copying it, go ahead and do that. I'm going to do the domain right here. You're going from 0. No, I almost got caught on that one. What's the first domain value here that we're going to consider? 6 point, was it 006? So 01 all the way to 106, and I need to peak, sorry. No, not 106, 102.07. And the first one, is that right? Yeah, 6.00 actually, if you round that one to 2 decimals. So that's my domain there. And the range is going to be from the lowest, which is 1 point. Can somebody help me with that one? Is it 1.87? The lowest? Yeah, thank you. 1.87 all the way to 10, where the wires are attached, right? So these are the restrictions that you need to put onto the function to simply talk about the cable, right? The cable itself. Due to climate change, engineers would like to model a bridge that will be higher off the ground. Write the equation that would represent such change. And so we're going to go ahead and do that. So basically what I do is I just copy the previous, and I'm just going to make that, I don't know, 18, something like that. State the new domain range based on G. G. How would you do this? Well, if you base it on this, so we all went with 18, obviously. Now your new highest point here, right? This is the 18 line. Okay, so we need to figure out the x values, right, of this, and we also need to figure out our new lowest point. Okay. So let's go ahead and do that. I'm going to go to y equals, and I'm going to go all the way to the end. This might take a minute or two. And I'm going to change that to 18 and delete the rest. You hit graph. Oh, I need to make my y2 equals to 18 now. I have a feeling that I'm going to change my window already. I'm going to change my y max to 40. I don't know, so 50. Let's go 50. So right now, don't worry about the points there, right? That's our previous question. We built a new bridge now. And so second trace 5. That's a 0 actually, right? Actually, I'm not giving you enough information because I don't tell you where they're anchored. I'm just saying that the bridge is not 18 meters high. So can we let's just erase this one. Too painful. Sometimes I get too ambitious with my questions here. Just cancel that one. Cancel. So 39, we're done with a quadratic. We did our cubic. And you guessed it, there are questions coming up here. So I want you to try, keep going here. I want you to go all the way to 44. So page 40. To 44, that's your homework. Lots of room. I may not have added a grid for all of them, so you might have to do it by hand. Do you remember what interpolate and extrapolate means? Do you remember those? Interpolate means you're trying to find points that are within the data that you've been given. Extrapolate means that based on the data, can you predict something down the road, like outside of your data set? So just use your calculator the way we would have done it, right? Second trace, whatever, to figure it out. And I will give you another hint. You can, when you have the years here, you can type it in exactly like that into your Y. This goes into L1 and this goes into L2. But some textbooks or some teachers will make this 6, 8, 9, and so forth. But you actually have a problem there. So you need to actually, because then you would go to 2, which wouldn't make sense, right? So actually you got to make this 0. No, that wouldn't work either. So just forget what I just said. Just type it in exactly like that, and you'll be fine. I know now how else you could do it. It just came to mind, but I wouldn't. I would just type it in exactly like that. So that's your year, and this is the distance traveled, right? So just try that. See if it's a linear or not. There's some more down the road. I want you to try them. I'm going to post the key to that. And I will have a regression AC waiting for you on Monday. Okay? What else do we have left? I'm basically going to give you a little bit of a review of the three types. Do you remember the three types of quadratics last year? Fencing, revenue, and story. It comes back. Okay? It comes back. So that's going to be a blast from the past. And after that, we're basically done. I'm just going to mix it all up. So we're not completely done, but we're really close.